I want to make this session really valuable for you. Okay? So, and because, Raquel, you're going to say yes.
Bueno, ella lo que quiere es que el taller sea útil para todos, o sea, que lo que hagamos sea significativo. Entonces, aunque ella haya seleccionado unos problemas de los 20 que podría haber elegido, pues en cualquier momento se puede cambiar la dirección del taller. Vale, un poco la idea. O sea, ella lo que me quiere sobre todo esta mañana, no sabíamos si la gente habla de inglés o no, si lo puedo observar, lo que ustedes hablaban y demás. Y si necesitaba un cambio, un giro, porque no estaba haciendo o significativo para los asistentes.
And if I talk too fast or you want to ask a question, please do that.
Si hablan muy rápido o quieren hacer una
And I don't know anything about your school curriculum. So what I want to do is I will need you to tell me what will be good for you.
Ella no sabe nada en absoluto del currículum escolar nuestro y que entonces lo que quiere es que nosotros un poco
It's wonderful to have you, Raquel. Okay, so this is what I thought we could do in the session. We will look at some problems. I have prepared 2,000 more. Basically, we wanted to solve the problems, and when you solve the problems, I would like you to be thinking about your solution, about the strategies that you find useful, about the content that these problems might be good to teach.
a través de sus problemas y no sé si es una tercera cosa.
What was the third?
Esa es la solución.
Then your next job, you will also be needing to think how students might solve these problems. You know, so because they will have a very different approach to students, to teachers.
Sí, la segunda cosa sobre la que deberíamos pensar es cómo lo harían los alumnos, cómo lo resolverían los alumnos, porque es muy probable que ellos tengan una aproximación al problema bastante distinta.
And then we will think about how we could use these problems in class.
Cómo podríamos usar esos problemas en clase.
And perhaps also talk about how we can, in the classroom, make a knowledge building classroom where people work together to help each other learn.
Y cómo podríamos hacer en clase para construir una clase que construya el conocimiento en el modo que explico esta mañana en la conferencia.
And maybe at the end, you could work perhaps and think about try to get a collection of problems that you might use for teaching something that you're interested in. So perhaps we could form some groups and you could do that.
Y al final a lo mejor podemos hacer una lista de problemas que se podrían usar o que querríamos usar para enseñar algún aspecto en particular, que quizás solo hagamos al final. A lo mejor no hace falta que traduzcan, es que me parece que todo el mundo lo está entendiendo. Yo soy solo profesora de matemáticas, y cometo errores. A la vez.
Oh, right. We don't need that one. Okay. This is a sign in a lunch shop. Do you have Donut King?
Yes.
Yes, okay. And my friend sent this email. He was waiting for a donut the other day and he saw the sign and it tells how many kilojoules. Kilojoules, yeah? Kilojoules for each sandwich. Okay. So he wants to know how many kilojoules there would be in a double cheese, 2-cheese sandwich. Would you like to have a go at this problem? Okay. So, and think about how you solve it. and that's how students would solve it while you do it. You've got some time. You can sit together, work together if you like, or work separately. ¿Todo el mundo sabe lo que pasa? Bueno, podría ser cualquiera. Sí, por ejemplo, así reemplazando, hacer la ecuación y después cuál es la doble, pero de cuál, de la más grande, ¿no? Are we ready? One more minute and then we will talk about it. Now this problem has a trick in it. Okay, would somebody like to write on the blackboard their solution? Do we have a volunteer, someone to write?
Se puede, lo que hay que buscar la combinación.
Yes.
No puede porque el dibujo
A volunteer to write it. Who would like to write what they have found? Yes, just write yes. Just give us in Spanish.
Ok, bueno, lo que yo pensé es hacer una ecuación y sustituir. Fácil, ¿no? Entonces cogí la de jamón más queso, sabemos que es 1820. Entonces de aquí sabemos que el queso sería 1800, de aquí dice el jamón. El jamón entonces es 1820 menos el queso. Después hice lo mismo con la de queso y tomate. Es igual a 1690 y después entonces el tomate va a ser igual a 1690. Tengo la mitad queso y después reemplazo. Entonces cogí la otra que es tomate más jamón más queso es igual a 1860, ¿no? Entonces me quedaría el tomate que está...
Who else knows this problem?
si era inicio del algebra quizá no hubieran entendido de todo esto bien.
Use it as a challenge. It's a challenge for the students to maybe to motivate them as an introductory activity to motivate the students into algebra.
And what do you think are the features of this problem that would make it good or bad for that?
For that all, maybe what is important is that it's a challenge or something that they have to, to search or to manipulate or something to do in order to solve it. Because they are going to feel more motivated, more encouraged to solve it.
Yeah, so one of its strong features is it's an attractive puzzle. Yes. And so many versions of this on the internet. What else do you think about a problem like this for teaching? Is it whether it's good features and its bad features?
Características que este es el problema válido, ¿no? Para plantear en clase, muy interesante. Y uno, por supuesto, es el atractivo. Hay muchas versiones de esto en internet, pero nos pregunta si hay otros aspectos que podrían ser positivos o negativos para usar esto en clase. Este problema en clase.
Primero motivador, motiva.
Motivating.
Motivating, yes. Do you think, I think unless students, sorry, I think this is the easy way into the problem, I think. One of the things that I would try to use this problem for is to help students to see if they try examples and work systematically, they can perhaps find important things and important reasons as a problem-solving strategy. Okay.
Can you repeat,
Yeah.
please?
Yes, sorry.
Paying attention.
One of the things I would use this problem for
Sí, uno de los aspectos por los que utilizaría este problema,
to show students
para mostrar a los estudiantes
that if they cannot see a reason when they want to explore, they should try special cases.
para demostrarles eso, que cuando no son capaces de entender porque algo funciona o porque pues que deben intentar, o sea, la estrategia de intentar con casos particulares, o sea, particularizar, es un poco para enseñar el heurístico.
And when they try cases, when they try special cases,
Cuando lo intentan con casos particulares, casos especiales,
sometimes you try anything, and sometimes you then need to try systematically.
a veces necesitas intentarlo, pero de una forma sistemática.
So this is systematic. And then, as well as just trying, you've got to start, even when you're looking at these cases, to start to look for reasons. Not just to say, oh, 54, 54, 54, 54, but try to look into the special cases to see what is happening in general.
Y mirando en cada uno de esos casos particulares, puedes a lo mejor preguntarte y encontrar lo que ocurre en general, ¿no?
So I think these are some of the ways that we can teach problem-solving strategies. The strategies are not complicated, but they are worthwhile talking about with students.
Que tenemos que enseñar las estrategias de resolución de problemas, porque aunque no sean difíciles, hay que hacerlas, o sea, hablarlas, decirlas, sí, verbalizarlas.
Another thing, I think it is very important for teachers when we are using a problem like this is to find how to use the student's idea, not just your own idea. So this, perhaps I don't know if these are too easy for you or too hard.
No sé si son muy difíciles o muy fáciles para ustedes.
So, these are two of the questions that were in the Japanese lessons about the parallelogram. Okay? And we could discuss, I think these are quite different sorts of problems. So the first one is to divide the shape the L
En el primero hay que dividir la L
into two parts with equal area,
en dos partes con la misma área,
one straight cut,
con un corte recto.
and the other one, this one, any point,
Hay un punto, cualquier
parallelogram,
un paralelogramo.
and we want to find the area of that plus that.
El área azul, la suma de los dos triángulos.
Okay.
Es igual a medio blanco.
A few minutes to solve these, to work on these two problems.
Excuse me. In the first one, we have to calculate how many ways to get the solution, or
I don't think you can. Yeah, but if you can, please do.
The grid is supposed to be a square grid or
The
rectangular
grid,
grid?
this grid is a square one, but it can be, just take any rectangle with a rectangle cut out of it.
Okay, because it looks like a rectangular grid, but not square from here. You know what I mean?
Yes, it's
But
just,
they are squares.
yes, it's just, I've probably named it.
Si decíamos que en el primer problema la cuadrícula no
So-
parece que sean cuadrados, sino rectángulos, pero son cuadrados.
So 90 degrees, rectangle minus rectangle. And if you've done that one, you could do this one.
Yo tenía que una vez y
If you know how to do this one, you might like to try this one. This is cake.
recuerdo sí, que justamente la día que me veía,
Icing.
porque yo compré el restaurante y me pasó la mitad.
Carmen, ese es como el del camino.
Half the icing, half the
Como el
cake.
del camino de tierra.
Sí,
El camino de tierra. del
Sí,
camino.
sí, todo el del camino de tierra.
The sweet on the top of the cake.
Okay.
The sweet. What's that called?
Merengue, maybe.
El azúcar ese que se pone.
Yeah,
It's like sugar.
Sugar. Yes, sugar. So cut half the icing and half the cake.
Vale, si ya saben hacer el de la L, se puede intentar el del cake, el de la tarta, que tiene azúcar. Hay que hacer un corte que quede la mitad de azúcar y la mitad de... Vamos a ver cuántas lenguas no hay 6 cuadrados, 9 rectángulos,
Specialising, generalising. Trying examples.
No, no son iguales, uno tiene
así porque yo le pregunté,
We'll do some more examples.
Tú piensas, hacer una reclamo y la línea pasa por el E y vuelve como los otros tienen
Reminds me, so we'll do some more. Yes.
La línea está clara, la línea tiene E y B.
yeah, she wants to cut the L shape through E on B.
Yeah, so that works if they're the same, in this case, because they're the same size. Now, generalise. Okay, now, any rectangle, any corner cut out. So it might be like this. Okay. So we can easily
Eso
do
sí.
this one.
Okay.
Now we're going to generalize to do this one.
Vale, estamos diciendo que la primera R es muy sencilla, la que tenemos ahí. Se cortan dos partes iguales trazando la recta que pasa por ahí. Pero, claro, ahora pasamos a generalizar. Vamos a imaginar cualquier rectángulo al que le quitamos el rectángulo de una esquina. Y entonces podemos tener algo parecido a lo que dibujó allí en segundo lugar, donde ya los rectángulos de los, ¿no?, que quedan en los extremos no son iguales.
Pero no es así. You draw the rectangle.
Este es fácil.
Imagine and then the same.
Do you want to show us?
No.
Why not?
Thank you.
I don't speak English very well.
I don't speak Spanish very well.
In this case, the solution is this. Here is the same.
The same?
No. Ah, it's here has the. Okay, I think it's the similar case. Pues ahora veré porque. Let me see.
Thank you. So, can I say here, when we are teaching problem solving, we have students who come and give a wrong solution. Okay. I'm sorry, I don't know. What is your name?
Sandra.
Sandra. So, what we need to do in a classroom is build a way that Sandra's contribution is valuable, even if it is not perfectly right, because it is so important that everybody shares their thinking. So Sandra has probably said what half of us are already thinking in our classroom, even with those terrible teenagers. You know, we have to get a way that they will be able to share their ideas without embarrassment.
Sí, lo que dice es que tenemos que buscar la forma en clase de que cualquier contribución, incluso si no es acertada, sea valiosa y que a partir de ahí se pueda seguir construyendo y que lo que ella a lo mejor hizo es lo que el 50%, la mitad de la clase estaba pensando. Entonces, pues, todo el mundo debe intentar expresar lo que ha pensado acerca del problema.
So by saying something that isn't really right, it still is helpful because many other students will have been thinking the same thing.
Pues aunque no fuera perfecto, porque no fuera correcto, pues que es útil porque es también lo que estaban pensando otro alumno.
So, has anyone thought about how they can solve this problem? Would anyone like to show? Would you like to show your solution?
Que si alguien otro lo ha hecho,
Would you like to?
Because I tried to cut.
Right, try to cut.
Yes, but it's not the same measure. Piece of paper, three squares and two. So just if I cut here, I have 2 and 2.
Right.
But I don't know if the same measure. Not.
Yes. So we have a special case here. So what you have done there is to try a special case and see how it can be solved.
Yes.
Yes. So, and that's,
This is the color.
so we've got a special case here. Others, has someone else tried special cases?
Lo que ella hizo con el trocito de papel, recortarlo y tal, fue un caso particular que le dio 3 por 2, ¿no? Pero claro, si alguien ha pensado otro caso particular.
I meant the general solution, but because you call it in the morning. Really good.
But here it is much more difficult to find, to look at special cases because there is more variation, I think. And in fact, I think this is not a good problem for children.
Si el verso es justamente lo mismo que la parte de abajo, que no sé qué decir. Si el trocito es justo a la mitad.
Yeah, I think her question is
La línea
the vertical, this vertical line is just at the middle of the length of the
No, cualquier división.
We don't know. So we know in the first case, yes, but in general, we want to do this in general.
the rectangle you take away can be any length and any width.
Yes,
Okay.
any length.
El rectángulo que se
Any
saca,
length, any width.
el rectángulo que sacamos puede ser tan ancho como nos permite el rectángulo inicial y tan alto como nos permite el rectángulo inicial.
So,
Is there any relation among the width of the angle?
oh, the angle.
Yes, because we
The right angle, rectangle. So 90 degrees. So always.
Because in this case, we have a 90 degrees angle and the length of the sides are the same.
Yes, in this one.
But in the other one is the double. And this is
Or
why
one
we
any. We could have any rectangle and cut out any square. Any rectangle.
So in the first one is the angle that we make is the half of of it. Yes or no?
I don't.
Because this angle is 49. You know? This one is 45. Sorry.
Yes, yes.
The length of here and here is the same.
No, maybe not. Yeah. Maybe.
Oh,
yes.
and this is there.
There it is, yes.
So maybe here, as the is a 90 degrees, maybe is the different the length among here and here is not the same. You know, there's a relationship among the length of this.
So we want a way of dividing when there is no relationship with the lengths.
Tenemos que buscar la forma de dividirlo cuando no hay relación entre las.
So why do I think that this is not a good problem for children to use it?
Quizá este no es
Maybe
un
we
buen
have
problema para los
difficulty for
niños.
finding the solution, and that's not a good problem for children.
Yes, so we have difficulty in finding the solution. But it's not just that it's difficult. It seems to me that this is a problem without a good way into the problem.
Dice que
Do you know?
quizá no es que sea tan difícil, o apropiado.
So I think in a classroom, it is easier to have problems that are difficult at the end, but it's nice to have an easy way to go into the problem. And it seems to me this is a very beautiful problem, a good puzzle, and we're going to see a solution in a moment. But it's not good for classroom use.
Se dice que este es un problema muy bello y que es un magnífico puzzle rompecabezas que ella nos va a enseñar la solución ahora mismo, pero que quizá no es para usar en clase, no es apropiado para usarlo en clase. Y que no porque sea difícil, sino porque puede haber problemas que sean muy difíciles al final, pero que se pueden haber introducido de una manera apropiada, ¿no?
So I think when you look at many of the books published, say by mathematicians, with mathematics puzzles, they're hard to use with children in a classroom.
Así que cuando cogemos libros editados para matemáticas, con puzzles y demás, que muchas veces no son apropiados para llevarlos a la clase con niños, son demasiado difíciles.
So when, as you teach with problems, you get a collection of problems that have got an easier way into them. It's hard at the end, but we want everybody to be able to start.
Que debemos hacernos con una colección de problemas que sean, aunque puedan ser difíciles al final, pero que al menos tengan una forma de introducirlo que sume a todos los alumnos, ¿no? Que todos los alumnos puedan entender el problema y ponerse a trabajar en él, hasta el final aunque sea difícil.
Would you like to show us your solution?
But not my solution, because this is the one.
Yes. You have very quick eyesight.
Bueno, la cosa es usar el hecho de que en un rectángulo, para dividirlo por la mitad, basta con que la recta pase por el centro. Esto divide por la mitad en dos áreas iguales. Por lo tanto, aquí, si divido por ejemplo así, y este es el centro, y este es el otro centro, esta recta divide los dos rectángulos por la mitad, por lo tanto divide toda la figura por la mitad.
Si lo haces en ese de arriba, en el de arriba, en ese, la línea pasaría a lo mejor por fuera.
Bueno, pues,
Pero entonces no serían dos partes, sino sería... La línea a lo mejor sale por fuera del...
podría ser.
Podría ser, ¿no?
Sí, te quedarían tres trozos.
Tres trozos en lugar de dos.
Yeah, she's saying that if the shape is like this one, yeah, and you use the line joining the two centers, the problem is you get 3 pieces instead of 2.
Very good. Okay. So we have, this is a very lovely solution, but not quite right.
Dice que esta es una solución adorable, no sé, como lo traducirías. Buena, pero
So
que
what can we
no
do?
siempre correcta.
Do you have an answer?
¿Tienes una respuesta? Only criticizing.
Could we do it? Is there another way we could do this?
Dice que hay otra
Could we
forma de
find a
hacerlo.
different line that would also...
Podríamos encontrar otra línea, otra
We
recta.
could always do a vertical line, just calculating, right?
Yeah, we could do a calculation. Yes, yes. Yes.
Could we count the squares? If we count the squares?
We don't know how big it is.
No.
Maybe you can split the other way in 2 rectangles.
Should come and show us. Thank you. You see how such an important question has come. Yes.
So
¿Se llama la norma o la?
I think the barrier dividing that way,
Yes.
and maybe the center is here now, and the center maybe is here, and this.
At the same
That's
could
a
happen.
solution.
Sorry, can you repeat this?
No.
More or less. So
So our problem was that the line, so the problem was that the line here went that way. Okay. And so what we find here now, there is another possibility. Oh,
Salir fuera.
you didn't want 2 pieces or 3 pieces?
that gives us 3 pieces.
You didn't want.
No,
Oh, sorry. I didn't. I misunderstood.
but we can have 3. We can have 3 pieces.
Okay.
Yes, but you were going to tell us there's another way. I think what you have said, we could do that one, this one,
Yeah.
We
No,
could
pero el
do
modo.
that one with that
Yeah,
one.
the same.
Yes, so that one in fact certainly And is somebody, can somebody think around this one? Yes? Show us one more.
Si en vez de usar estos dos centros, usamos el centro de este y el del grande,
Ah, ese ya es. Ese sí.
ya, porque si es la
Sí, sí.
mitad del
Ah,
otro,
ok.
Sí, sí, con ese ya sale siempre. ¿no?
si usas los dos otros y así te sale.
Sí, sí, así sí te sale. Claro. ¿El centro de aquí?
I was thinking which are the previous knowledge that the learner needs in order to try to don't frustrate because it's try and don't have.
Yes. So in the Japanese lessons about parallelograms, the of the parallelogram divides it into two equal areas.
And which is the name of this property or
Normal, centro sale.
Yes.
feature?
So,
Science tree.
It's just for example. Okay.
so in the Japanese lessons, this comes as a difficult example after they have learned this. But it is very hard to think it up for yourself, isn't it? Yes. So, but what we see here is even though this problem was hard to start, when we get the idea, there is still quite a number of different ways that we can use the solution and adapt the solution. So this one here that we needed, this one was addition of two areas, and this one was a subtraction. If you look at the subtraction. So we had, after we got started on the problem, we could look. Okay. Okay. This one, I think it's much easier. Much easier. Would you like to spend a little bit of time? So this one, any point in the middle, any parallelogram. This is 4 times 6, but it could be any parallelogram. So the area of that one plus that one.
¿El punto del centro es aleatorio?
Sí,
El punto del
sí, sí,
centro
sí,
es
sí, sí.
aleatorio.
Sí, es un punto dentro del paralelogramo, ¿sí? Y a partir de ahí lo unes con los 4 vértices. Entonces te quedan 4 triángulos. Sería calcular el área de los triángulos.
Mide 12 el área 12 secuencial, sí, el punto del área de sí, marcar horizontalmente el doble de los dos paralelogramos dentro del cual hay un triángulo. Por tanto, el triángulo es la mitad del paralelogramo, siempre es la mitad. Yo que sí trabajo con Julia, con el chico de geografía.
Well, she says that she's got the answer, that the area is always 12 square centimeters. And she explained to me, but I couldn't understand it, even when it was in Spanish. This is the siesta time.
Yes. Triángulo es la mitad del
The
paralelogramo.
triangle is half, or has half the area of the parallelogram.
This
The
one
top
is
parallel.
parallel to this one.
Yeah.
Parallel, parallel, parallel.
Yeah.
Y este, la mitad de este de aquí.
And the triangle at the bottom is half of the area of the parallelogram at the bottom,
Because
the triangles are equal.
Sí, traza la pantalla también.
Los ángulos.
Yeah. We've got 4 pairs of equal triangles. So 4 are shaded,
Yes.
and the other 4 are not shaded. So.
Good, thank you. So it is always half of the area of the parallelogram.
Yeah.
Has somebody got a different way of solving this one? Any other ideas for this one?
Well, if you multiply base times height as the sum of both heights. Oh no, forget about it. Sorry. The sum of the heights is not 4.
Si 4 es la altura del paralelogramo, sí.
Pero 4 no es la altura del paralelogramo.
Bueno, pues la suma de las alturas será la altura del paralelogramo. O sea, si es 4 o el número que sea.
Claro, pero que porque antes cometimos un error porque dijimos 6 por 4, 24 y 4 no es en la altura.
Sí, la altura, por ahí.
Ah, sorry. I thought that 4 was the length of the side, but it's the height. Yeah.
It is.
So yes, it's what it.
Yes, it could be. Yes.
Yeah, I couldn't see
Yes,
the.
yes, the faint.
Yeah.
Yeah,
Okay.
faint height.
Yeah. Okay. So.
4 is the height there.
Yeah. So the base of both triangles is 6, and the sum of both heights is 4. So if you multiply
Yes.
base times height and divide by 2, of course.
Is it obvious that the sum of both the heights is 4? I think it has to be that you can draw, when you draw a line perpendicular to that, there, it will also be perpendicular to there. It's not quite obvious, is it? So here we have another problem that in the Japanese parallelogram lessons that I showed this morning, these problems are being used for deepening the knowledge of the students on what they've already been taught. So we'd expect that students here were knowing that they would look for this sort of relationship to make it the sort of problem that many students would be able to solve.
Sí, bueno, ella preguntaba ahora si era tan evidente que la suma de las alturas era 4, porque claro, si tú trazas una perpendicular desde el lado superior, digamos, estás seguro de que es perpendicular al lado inferior, por supuesto que porque son paralelas, ¿no? Pero que la secuencia que nos presentó esta mañana sobre, ¿se acuerdan? La japonesa, y toda sobre paralelogramo, pues que un poco en esa secuencia se trataba de profundizar en estas cuestiones, en hacerte ese tipo de preguntas.
So I think for this section, not all problems are good for use in class. Yeah, and we need to create a good way into problems and also making sure that there is some depth and that we learn from them in each case. These problems here from Japanese lessons, they were in the situation of students having studied that topic and the students knew they were about that topic. So it's different to coming fresh and having to solve this problem, which is more homework for you. Okay?
I think what you meant is that after having a sequence of activity like the Japanese one,
Yes.
you are ready to introduce this kind of progress,
Yes.
but not without that training before.
Yes.
Maybe it's very hard for students to. Okay, sí, lo que dice es que bueno, que después de llevar una secuencia de actividades como la secuencia japonesa que presentó esta mañana, pues que estos problemas, siempre que se traten de modo adecuado y con la profundidad necesaria, pues están muy bien para llevarlos al aula. Que claro que sin esa instrucción previa.
Bueno, manipulativamente, recortando, los chicos llegan a seguir
Yeah, is on-hand activities, in which you can cut out pieces and put them together and puzzles. Students get to this kind of.
But I'm sorry, but I have not been able to bring you hands-on activities.
Sé que siempre no haber traído actividades manipulativas.
So what we use to chefs as our good previous knowledge to work with our learners before introduce that kind of activities or problem solving.
Yes, so in the Japanese context are good at the end of a unit of work. But if you also need sometimes to give students problems that they can use any mathematics to solve, but they will have to have a different shape, to the problem.
Lo que dice es que en el contexto japonés estas son actividades ya de finalización de unidad, pero que a veces también se debe proponer a los estudiantes problemas que puedan abordar con cualquier matemática que sepan, ¿no? Y no como finalización de una secuencia de actividades, la cual van a aplicar unos métodos para los entrenados. Yo lo entendí así.
Okay. Perhaps we could have a look at one more problem that's easier to get into. Okay. And then after that, I will ask you what topics you would like to do some problems on. Okay.
Dar otro problema y que después ya seremos nosotros los que propongamos sobre qué temas queremos plantear.
Let me know. Does anybody know this problem? We won't do it if you do it. This number is the sum of three consecutive numbers. This number is the sum of consecutive numbers. So my question to you is, which numbers are the sum of consecutive numbers?
¿Qué números son la suma de números consecutivos?
And if I give you a number, 157,
Se nos da un número, 159.
what is that the sum of consecutive numbers?
Es la suma de números
And if
consecutivos.
so, which numbers?
¿Y de qué números consecutivos es suma? O sea, ¿qué tipo de números son la suma de números consecutivos? Y si nos da uno, por ejemplo 159, es un número que se obtiene como suma de números consecutivos, y en ese caso, ¿cuáles son los números consecutivos que se han sumado para obtenerlo?
Progresión aritmética. Con progresión aritmética de la diferencial.
Pero se supone que solo lo vamos a hacer.
Que depende con qué nivel estés trabajando con los chicos.
¿Cuál es el number?
Has anyone done this problem before? You have.
Maybe I remember a mathematician with 10 years.
Good. Well, you will remember. There is so much to do in this. You can. Well, I'm not going to tell you what you can do, but you will be able to find it. Okay, so which numbers do we have that are the sum of consecutive numbers? This is another problem where you can pretend you're 10 years old or pretend you're 60 years old. Anyway. When you're solving the problem, please think, notice, solve it in your head and also watch yourself from above to see what you are doing. So you've just got in the number of numbers left. So you're not in the close.
I think we have this is my number.
Right.
Possible to put
Is the number of card numbers. We have 3 numbers. Yes, 3. But we have 2 on the cards. 10
¿Cuántos números consecutivos hay muchas soluciones entonces? Hay muchas soluciones. Pueden haber muchas soluciones. Yo encontré el
mucho y al final... Y 180. Que parece no
A ver, pues, una redonda is now. Minus 1. Entonces we have three numbers.
You're going to come and show us on the board?
Todavía hay gente explorando y buscando algunas nuevas ideas, ¿es así?
Maybe we have some people who have moved into another stage of problem solving, but I think most are still exploring. Tell me your...
As you give us three numbers,
Say three numbers,
I
yes.
just divided this into 3, and 60, and then try.
60.
Sorry. And that's all. And then my partner
Yes.
have another idea, if you can explain, because she's.
You ask which numbers are you can put them.
Yes, which you can.
So if you have si el número es impar,
If the number is odd, si el número es impar,
si el número es impar, se va a poder poner como suma de números consecutivos porque
you can always express it as the sum of consecutive numbers.
Odd number.
Yeah, if it's an odd number. Why?
181.
You can always express it as sum of two consecutive numbers.
Okay. So, I guess, put up your hand. Who found that all of the odd numbers are the sum of two consecutive numbers? Most people find that.
No.
Suma de par con impar siempre.
Yeah, but I was estaba buscando
Okay.
la
So
suma
we
que
know
vamos a
that all the odd numbers are sums of consecutive numbers. So that only leaves an infinite number of numbers, all the evens, for us to work on.
Así que ahora solamente nos quedan los pares para trabajar.
y los pares se pueden poner también como suma, pero no de dos sumandos, sino tienen que ser un número impar de sumandos.
She thinks the even numbers can also be expressed as consecutive numbers, but more than two. You
More
have
than
to-
two numbers.
More than two numbers.
3, 5, 7.
3, 5.
Always
An odd number of
Always an odd number of numbers.
Sí, siempre un número impar de número.
Center is odd.
So, would you like to tell it?
With the center, if you have 3 or 5 or 7, some.
Can you show us?
So we want to express the sum.
Yes.
Okay. So you have, if you want to express with 3
We just
elements, consecutive elements, so the center one has to be
60.
60.
par.
Even, yeah, even and odd.
Okay. That's because it goes odd, even, odd, adding up to even. But if it was even, odd, even, it would add up to an odd number.
Yeah.
Yeah, but what they say is that you need terms or 5 terms or 7 terms. An odd number of terms, you know, in the sum.
So to make it an odd number of terms, the centre number has to be even. Okay, it's complicated.
Yeah.
In our head. So we have a lot of different conjectures now. Some other findings.
Otros
ideas.
hallazgos, otras ideas, otros...
Multiples of 5 can be expressed as 5 consecutive numbers, multiples of 7 can be expressed as 7 consecutive numbers. And I think powers of
7.
Powers of 2 cannot be right.
So would you like to come and show us the multiples of 7?
Where I have, I just said that.
Just give us an example. So we'll do 56. So we do, or maybe we'll do a bigger. Shall we do 700? 700.
But it's the same that she did so, but we
Yes,
invite
you
people.
need to show. No, it's not the same because this is just saying whether that's even or odd. So we've taken 700. It's a multiple of 7. So the idea here is that this is a sum of 7 numbers.
Lo que quiere mostrar es que los múltiplos de 7 se pueden expresar como la suma de 7 números consecutivos. Todos los múltiplos de 7.
But yes, it's the same idea that she said, that you divide and you put it in the middle, and you can do with every prime number here.
Every prime number?
Except 2, I think.
Right, okay. Only prime numbers?
Not everyone, but yeah, not with
Right.
every number that
Okay.
you can.
So what we've got here is a proposal very close to a proof, isn't it? That if we've got a multiple, let's say of 7, and we take it, then 1, 2, 3, 4, 5, 6, 7, we've got 100 there, we've got 100 and 100, averaging out, 100 and 100 there, and 100 and 100 there. So that's going to add up to 700. If we've got the average, this is the average, and we've got 7 numbers with that average. So we know now that every multiple of 7,
Excluding 7.
excluding 7. Oh, surely not.
No.
Surely. Do we have to exclude 7?
7 is 3 plus 4, so it's... you
Yeah,
can
but you
express-
cannot express it as the
Come
sum
on,
of
come and do it.
7.
Sorry, come and
Yeah, Oliver.
let's come and follow this rule. Come on, here you go.
What do you
Follow
want me to
that.
do?
Follow, I'm sorry, I don't know your name. Georgina's rule.
What do you want me to do? Show
7.
The problem is
So what's the middle?
If you put 1,
Yep.
and can you use negative numbers? Okay, if you can use negative numbers, it's okay.
Come on, let's see what happens here. So minus 2 plus minus 1 plus 0 plus 1 plus 2 plus 3 plus 4. And when you clean that up a little bit, yes, yeah. So, oops, that's 3 plus 4. So we already knew right at the beginning, didn't we, that if we have an odd number like 7, we can write it as 2 in the middle.
Yeah.
And it's exactly the same finding that we had a minute ago. We can take 7 is 7 ones, put these numbers around the outside. When we minus, it is the sum here of 7 consecutive numbers. You'll get odd bit unusual numbers. And then when we think about it, this, the 4 plus 3 that we always knew about, is kind of that same pattern. Which is nice, isn't it?
Yeah,
Yes. It's good. So, let's just go back before we go on. I know we've got to go on because we've got a solution up the back here that we want to talk about. With children, this problem is very important for thinking about different ways of specialising. So,
Dice que este problema es muy bueno para pensar en distintas formas de particularizar. Cada uno particularizó como quiso, los múltiplos de 7, los impares, los pares.
Educación personalizada.
so after we try some examples, it's a good idea to do and see what they did. And I'm sure, did some of you do this? Start this way, try the numbers.
Está preguntando si alguno de nosotros intentó probar con números particulares, pero de una forma sistemática, por ejemplo, ordenándolo en una tabla o en una lista.
Did anyone else, did other people try systematically but in a different way?
Alguien lo intentó hacer de un modo sistemático, pero a lo mejor de una forma distinta a la que ella tiene ahí, ¿no? Well, she tried to use the formula for arithmetic progressions.
Yes, which is useful at the end. Yes. Another way of starting to specialise is to do, I think, this sort of specialisation. For children, because this starts to give us a pattern, 6, 9, 12, 15, and we can start to see 3 5s coming out of that pattern. So we've got this way of specialising, and we've got this way, which we might allow that as 2. Can we do 2? Can we do it with negative numbers? Plus 1 plus minus, what is it? Minus 1 plus 0 plus 1 plus 2. Oh, that's a bit funny, is it? Well, is that right? Okay. Then we've got 1 plus 2 here. We've got 4. What's 4? How do we get 4? Children probably won't get 4. Okay, then we've got 2 plus 3. We've got 1 plus 2 plus 3. 3 plus 4. 8. Going to get that. 4 plus 5 for 9, and also 2 plus 3 plus 4, which is 3 3s. 3 plus 3 3s. So we've got, I think this is an interesting problem for children, because we want to be able, when they're working their way into the problem, they've got 2 ways of looking at examples. They've got this way, taking the numbers and writing them down to get a conjecture, and they've got this way here, which is taking the sums and writing them down to see a different conjecture.
Aquí tienen 2 modos de, digamos, proceder de forma sistemática. Una sería, primero ponemos lo que queremos de resultado y tratamos de buscar la suma, y la otra sería al revés, de forma sistemática voy escribiendo las sumas y voy obteniendo los resultados. Y según sea una u otra puedo llegar a distintas conjeturas.
Now, would you like to tell us about your idea? Coming right,
Casi, sí,
rub this off. I'm going to rub your homework off the board in half, so the same amount of icing, the same amount of cake for 2 people.
We have a number, cualquier número.
Sí, tenemos cualquier. Yeah, we've got.
And I wanted to put in sumando.
Yeah, she wants to express it as the sum of n terms,
In numbers.
n numbers,
Consecutive numbers.
consecutive numbers.
Then I think this number is number plus 1, number plus 2, number plus, okay. Then if we have this no?
Yeah.
And we can divide between n all number. The solution of this operation.
María, ¿tú quieres que te
Sí.
traduzca al español?
Sí.
Es que tú estás hablando inglés.
No, te digo.
Si tú estás hablando inglés, yo te traduzco al español.
Esta operación.
Ya.
No, si B tiene solución entera en esta operación, quiere decir que B lo puedo poner como n sumando consecutivos.
Yeah,
¿no?
she wants to say that if she subtracts 1 plus 2 plus from B and then divide by n, and the answer, the result is an integer, so it means that B can be expressed as the sum of n consecutive numbers.
Okay. So let us now, we have, please stay, we have a conjecture here that's a bit hard to understand. So, if this was happening in your classroom, what would be good questions to be asking so that we could all begin to understand and find out if this is correct? So you let's stay there. You're now a student. We're all students.
Lo que ella quiere decir
What
es que
could we
esta,
ask to help us understand?
esta forma de presentarlo sería compleja, ¿no? Difícil de entender. Entonces, ¿qué pregunta, si un alumno formula esta conjetura, ¿no? ¿Qué preguntas podrían hacer el resto de alumnos de forma que se fuera clarificando lo que ella ha querido explicar?
What is it that we need to know?
Nosotros. Creo que tú lo has expuesto y ella quiere que nosotros...
Creo que me pregunten, ¿no? Ustedes me pregunten.
Sí, que te preguntemos.
Maybe if I present you an example, can you understand? For example, I have a number 102, no? And I want to put this number in three numbers.
As the sum of 3 consecutive numbers.
The first numbers, the second number is this number
Plus 1.
And the third number is number plus 2. Then for this addition is the result to 0 plus 1 plus 2. If I wanted to put in four numbers, 0 plus 1 plus 2 plus 3, always the same. If I restar minus, subtract this sequence, we have the same number. The same number 3 times in this case, if you wanted to put in terms. This if b minus 0 plus 1 plus 2 is divisible for 3,
divisible
then
by 3
it's
means
always
that was my idea too.
Yes, and this summa, we can write like this product. Because 1 plus 2 plus m es, si le añado al revés, esta es la prueba Exogao, ¿no? Cuando dio el...
This is the Gauss problem. The additional.
Más 1, tendré aquí que dos veces eso es n, porque cada uno de estos sumandos me da n, por n menos 1. ¿Vale? I think the students, it's difficult for the students, but the goal is llegar here, ¿no?
Any other questions? Yeah, no, I think I understand. Are there other questions we should be asking to properly understand this? Does anyone have any queries, any questions? So would you hope that your students might?
Well, I tried this one too, but what I did is, well, if I wanted to express it as the sum of two numbers, so I have to subtract 1. If I subtract 1 from the number, it's divisible by 2, so I can do it. If I want to express it, so it's just the same. The next sum is 1 plus 2, 3. So if I subtract 3 from the number and it's still divisible by 3, it means I can express it. The next sum is 6. So 1 plus 2 plus 3 is 6, so subtract 6. Check if it's divisible by 4. If it's divisible by 4, it's okay. And I think it's quite.
So we have two ways, don't we, of finding, expressing a number. Is this a new method or the old method said in a different way?
Pregunta que si este es un método nuevo o es el mismo método de antes, planteado, propuesto un modo distinto.
How has this method improved our understanding? Or has it improved our understanding? It is nice that it links the sum with, we're seeing the 1 plus 2.
I think it's the same, but for different levels, because for some, depending on the learner's level, they can reach the solution or not. But basically it's the same, but we can understand. I understand the same, but not for every student it's suitable.
Yes, not in this, but probably in this way. It would be good, yes. So I think, why aren't you just saying that 102 can be expressed as a sum of 3 numbers if 102 is divisible by 3? Why didn't you just say that? Because I can cancel out this and this one, can't I? This bit's always a multiple of the n. If that's an odd number, this will be a multiple of n. So it really just depends whether b is a multiple. Nearly. So I think we've got something a little bit hidden here under the algebra.
Sé que aquí hay algo pequeño escondido detrás del álgebra que no estamos viendo. Porque ella opina, ¿por qué no partimos de que 102 ya es múltiplo de 3 y...
Sí, que la división es 102.
So I think, thank you for this. And what you've done is linked the sum of the arithmetic progression and seen this one exactly the same. Did anyone use the formula for arithmetic progression, but just starting m and going to n?
Dice que si alguien utilizó la fórmula de la progresión aritmética de la suma, pero no empezando desde 1 en adelante, sino del término m al término n.
Did you try that?
¿Tú lo hiciste así? Cogiste la suma partiendo del término n hasta el término n, no empezando del término 1.
No, le puse a su 1, pero no soy sin.
Sí, pero para tirar n.
Claro.
Yeah, she did.
She did, yes. Did you find it helpful?
¿Lo encontraste útil?
Para mi alumna,
her students?
utilizaría más
She would use
investigación.
some investigation.
Suma dos números consecutivos,
For example, add 2 consecutive numbers
saca conclusión
and reach some conclusions.
de los resultados.
Yes, yes.
Y luego suma tres números
Then
consecutivos,
add 3 consecutive numbers.
busca regularidades.
Try to find some patterns or regularities.
Good, yes. Okay, so could you just spend a moment just talking with the person alongside you? What do you think that, how would we now answer the question? What do we now know? Which numbers can be written as the sum of consecutive numbers? And if I give you a number, say 700, how can you find out how to write it as a sum? Okay, can you let's just summarise, just perhaps we're talking with one other person. What is the simplest thing, the simplest answer that we have now found to that to those two questions?
Si ella ahora querría que con la persona que tenemos al lado llegáramos a o escribiéramos las conclusiones a las que hemos llegado, qué números pueden escribirse como suma de números consecutivos y cómo podemos escribirlos a los que saben.
And is allowed the using of negative numbers?
Oh, well, up to you.
Or
Do you
we
want
can
to?
Entonces se pueden usar números negativos y ella dijo que bueno, que depende de cómo quieras plantear tu problema.
One of the
Que
things
depende
we
de
found is that negative numbers
decimales.
Yes.
Si usamos decimal, el consecutivo de 2,3 es 2,4. Es que depende del número decimal que utilice. Sí, claro. Con los negativos pasa lo mismo. Yo lo pienso los chicos míos. Negativos, así de momento yo me los parto en puntos. Solamente puedo conseguir. Si son todos números, tiene que ser tiene que poder ser dividido entre es un divisor. El del medio.
Maybe one more minute for writing.
Nosotros vamos a ver.
Sums of 4 and 8. Okay.
Porque si tienes que quedar los medios, sí, tienes que quedar los medios.
Okay, next pair. Could you just give us, or would you like to tell us one other pair? Next pair, what was your best finding? Your best finding?
we found a formula for. Can I write?
Formula
For characterizing.
okay.
For differentiate numbers that can be written with a sum of any terms in a consecutive number.
Is it? Will you write your form? Do you want to write the formula up here? Okay. So we've now got another formula. So let's put the easy things down there, the formulas up in here. K divides N. Yes. Then. Can everyone read this?
Pues
¿Todo el mundo puede
sí,
entender?
sí,
Is it true?
No.
I'm not sure.
No.
Except K equals 2 or any other. For this, if K is 7, this sentence makes no sense because there is no central term.
Okay,
Okay,
so
so
K is odd.
Okay, so.
Yeah, so if K is odd, that works. If K is even, we've got some more homework to do.
bad means even? Is it bad?
Sí.
No, K is
Different to
cuando dice cuando
no centre.
Okay, so
So we've got a problem here. K is an odd number. So we've got
Average.
But
Average. Instead of central number, the average number.
yeah.
well, okay, maybe I can put an example and explain the idea. Yeah. Yeah, that's right.
But sorry, why should n be even?
Okay, let me explain. Okay, I will
Because, for example,
erase everything and let's regrade after. So, okay, so we saw that, or we discovered that if we have odd number of terms in
Yes.
sum, okay, so we can join in pairs, and we had 33.
Yes, 25.
No.
25.
I have
No, it's going to
some
be-
calculations here.
It's going to be 5 fives. 1, 2, 3,
Yeah.
4, 5 fives.
25.
25.
So it's odd.
Entonces sumamos mal antes, ¿no?
¿Ve?
Sumamos mal,
¿Cuál?
le sumamos mal antes.
They made a mistake in calculations.
I think I wrote it so too fast.
Yes.
So I will.
No, leave it because it's perfectly good, isn't it? If we have an odd number, then we have a central term. So if we have a number like 700, it's divisible by 7. So it's going to be the sum of 7 terms with the middle one 100.
Sí, si tenemos un número
It's
como
divisible by
7,
5.
podemos poner
So it's going to be the sum of 5 terms with a middle number 140. It's divisible by anything else?
Which?
25. It's going to be the sum of 25 terms with a middle number of 14. Just squeezing past, not getting into the negatives, won't it? So yours is this is good here.
Okay.
Is K's odd.
Okay, so
So we've almost done K's odd, I think.
sorry.
For odd number, K, we now have a way of telling. And it's the same as the formula up the back, the formula here, but it expressed differently.
Tenemos una regla, pero solamente para los pares, y se vendría a ser la que presentó María.
And did anyone think about the sum of an even number of terms?
¿Ha pensado María acerca de la suma de un número par de términos, de números consecutivos?
Did anyone think about it? It fits the formula, this formula here, would be able to fit. Okay, but has anyone thought about it yet? I think you might, have you?
No, I think this covers all cases except n being a power of 2,
Yes.
but I don't know what.
Yeah, so this says that every number that's got an odd factor can be written as the sum of squares. Which numbers don't have an odd factor? Just the powers of 2. Well, they have got the odd factor of 1. Sorry? They have got the odd factor of 1, which means they can be written as the sum of themselves. Yeah, not very satisfactory. Yeah. So we have answered the question of which ones can be, and we've gone part of the way to answering how. We've still got sums of odd numbers of numbers that we haven't done. But I think if we were going to use this with a class, you'd try to, oops, sorry, I keep kicking it. We try to cut, to control the, you know, by looking at you know, a part of it, which numbers could be the sum of 5 numbers, which numbers are the sum of 3 numbers, that sort of thing, as well as going around the other way. And there's 2 sorts of specialising down that way, and then the specialising from the sums of 2 numbers, sums of 3 numbers, sums of 4 numbers, sums of 5, and trying to find the patterns. So very well done on that problem.
Lo que dijo ahora es que este problema tendríamos que acotarlo si lo llevamos al aula. O sea, ponerle límites hasta donde queremos llegar y a lo mejor pues cuáles podemos expresar como suma de 2 términos, de 2 números consecutivos o de 3, y luego usar las 2 formas de particularizar, ¿no? La de poner los números y tratar de buscar las sumas, y poner la suma y ver qué tipo de números hay. Y que lo hemos hecho muy bien.
Okay. Now we've got some time left, and so I would like to know, what would you like to do now? I've got 2 suggestions. We could work through some more problems in the way we have been doing before, or another option is you could think of some topics that you would like, you know, some school topics that you would like some problems, and we could work together to get some problems for teaching those topics. So is there an interest, say, in that second idea?
La idea es que ahora nos queda todavía tiempo y que a ella le gustaría que nosotros decidamos lo que queremos hacer, que podríamos seguir trabajando en problemas que ella proponga como lo hemos hecho hasta ahora, o que podríamos buscar a lo mejor un tema sobre el que nos gustaría trabajar problemas y ahondar en ello. Maria says that why don't you go on proposing or suggesting what problems? Yeah.
Do some more problems.
Yeah.
Would you like some geometry? Yeah. Or,
Can we do a question?
yes.
How are you interested about using GeoGebra or some modelization system for children?
Shall we do a geometry problem where we use GeoGebra as well?
Bien, él le preguntó
Let's give me
por
just
cómo
take
veía
a
ella lo
little
de
bit.
usar GeoGebra, ¿no?
O un sistema de modelización.
Sí, y ella me dice que, bueno, que va a proponer un problema de geometría usando GeoGebra.
Usamos GeoGebra también para problemas que no son de geometría.
Sí. Carmen says that we use GeoGebra not only for geometrical problems, but for all sorts of mathematical problems. Some of us,
Yes,
not everybody
yes.
does.
Yes,
but
yes.
some of us.
Yeah, so GeoGebra is it's now a very nice tool
Yeah.
for secondary mathematics. Yeah. So very nice to explore problems, and also nice for teachers to demonstrate. And of course the algebra is very nice. It's nice that you can see the algebra window as well as the other things. Now I'll show you one of the curriculum things that we've been doing in our curriculum
Está de
project.
acuerdo contigo, ¿vale? Que claramente es una herramienta que tiene un entorno algebraico.
Por ejemplo, le sumo, le bajo.
GeoGebra that it's, for most of the time, it's better for us to make our own files rather than to have students make files. So we are ways, it's not worth it, the students should do something with the GeoGebra files rather than make it from the beginning.
Lo que dice es que la mayor parte de las veces merece mucho más la pena llevar ya los ficheros preparados y que los alumnos hagan lo que se espera que hagan, pero no que ellos, digamos, si hagan el documento, sino el archivo.
So, in our curriculum project, we have made a series of, for Year 7 geometry, Year 8 geometry, Year 9 and Year 10 geometry, we have designed a series of lessons, each of which is about, in English, it's called a mechanical linkage. Mechanical linkage. Yeah, so just don't translate mechanical linkage, just say the rest. Yeah. So for Year 7, Year 8, Year 9, Year 10 geometry. Now, a mechanical linkage is something made out of rigid bars, and do you know what I mean? A car jack to change the wheel of a car. Yeah. And these bars, you can see a picture. So this is GeoGebra file. You can see that it's made out of metal, but the metal can change orientation. But the bars, this doesn't change length. They don't change length. So this car jack is made out of a little part at the bottom, a part on the top where you put the axle of the car, and then this is a screw. Another example is an ironing board. Do you have ironing clothes? Okay.
Una tabla de planchar como se cruzan las piernas, ¿no?
Rigid bars, and you can change the height of the board, but you can't change the length. So we have taken these and made a series of geometry lessons. And we're hoping to do two things from these. One is to show students about mathematics in the real world, that geometry is really important in the real world, and also to show them the importance of proof. So one of the things about GeoGebra is sometimes when you know, the proof, you don't have to prove because you can see. So we've also tried to get proof from this one. So
que han dicho que han hecho una serie de lecciones desde el grado 7, ¿no?, al grado 10, basadas en el gato, el sistema del gato y el sistema de las tablas de planchar para abrir y subir y regular, y que con eso persiguen dos cosas, por una parte conectar la geometría con el mundo real y por otro lado tratar la importancia de la demostración o de la prueba, porque parece como que en geometría a veces no hay que probar nada porque es obvio, porque lo vemos. Pues la necesidad de justificación, ¿no?
All of our lessons are on the web. You can download our GeoGebra files. You can change them to Spanish.
Dicen que todos estos recursos, toda esta serie se puede descargar y cambiarlo al español y usar.
So I hope this.
Son archivos de GeoGebra.
So in real life, you turn the handle on the screw for it to go up and down, but in GeoGebra you drag point D.
Dice que la vida real le das vuelta a la manivela para que el tornillo gire y tal, pero que aquí con que arrastres el punto vale.
So what we want students to know, to find out, is why does this shape move the car vertically upwards?
La primera pregunta sería ¿por qué este sistema consigue levantar el coche hacia arriba?
If we have the car on a level at the bottom, this part here is level at the bottom. We want the car to just go up. We don't want it going sideways and falling off.
Así que no queremos que el coche se caiga hacia los lados, sino que se levante hacia arriba.
So would you like to think about that? So in this lesson, we give students, first of all, plastic strips to make the linkage. We call them geostrips. We can
Dice que
buy these
primero se
easily.
dan como unas tiras de plástico
Un
para...
geoplano.
Ah, un geoplano.
Sería, ¿no?
Plano con elástico.
Con elásticos, ¿no?
No, con unas barritas de plástico.
Sí, sí, eso. Con unos palos de helado con
Plastic,
un
yeah, not as you need to be able to pin together.
Yeah.
Yes, with
Yes,
Como unos sticks with
Yeah.
holes.
yes, sticks with holes, yes. So we start with the real car jack. The teacher has to bring her own to the classroom. Then we get them to make with geo strips, plastic strips, and you get a physical feel for that. And then we do it in GeoGebra. So we're really mathematising, making the mathematics more abstract at each stage. The car jack, the geo strips, the GeoGebra has thin lines, points, that sort of thing, and then we want the proof that the car will go straight up.
Así que está matematizando cada vez más, primero desde lo más real a lo más abstracto, ¿no? Primero
Sí,
con el gato,
manipulativo.
después el gato se moviliza con las angelitas, después se pasa. Y
So
al final la prueba.
But would you like 1 or 2 minutes to think, why does this shape make the car go vertically upwards or downwards? Okay? Prove. We want to know, when I move this, why does this part go straight up and down? What's it here?
If you move
Because of the
Of course,
symmetry of the
these are
shape.
all correct things, aren't they? Yeah. So we make it. We just did. Modelling is to think of this as a rhombus. Okay, so in mathematical modelling, going from the real world to mathematics, we have to make assumptions. So that's done just over here. Here's the ground. This one, that's here. And I guess we would think that so what we need to know is to why the line AC, if I put that one in, would always be at right angles. And so because of the rhombus, we have the diagonals of the rhombus crossing at right angles. So that diagonal line will always be at right angles. It crosses at right angles in there. So that's one of the ways that we've been using GeoGebra. So with prepared lessons. Shall I just show you another one of these? This one's nice. Or folding umbrella. That is a mechanical linkage. see if the cherry picker works. Please work. I've just got a slight difference in the the number of pixels on my screen, so this one's not showing so well. But for the
Maybe if you try with the view,
yes. No, I don't think that will.
On your right.
Antonio, tiene un problema con la pantalla.
Other side.
Que tiene un problema con la
Con la
pantalla.
configuración de los píxeles y por eso no se le ve completo.
Sí, tiene que bajarle.
¿Lo puedes bajar? Porque ya...
Pues no lo sé.
There.
Aquí está la configuración ahí.
Advance.
Advanced.
Advanced.
You can make zoom there.
Well, let's not. We won't worry about it. Okay. So we call this a cherry picker. Now, a cherry is a little fruit.
Yes.
Okay. And it's to go up high and pick the fruit off the tree. But also to fix the light in the street.
También para arreglar las luces en la calle.
So what is your name for a cherry?
Grúa, como llamamos a esto, grúa.
Sí, elevador. Elevator, sí.
Elevador, grúa. Nothing to do with cherries.
Nothing to do with cherries. So what are the important real-world properties for cherry picker? What do you want when a cherry picker moves? Yes?
To move higher.
To move high, yes. So it has to go up very high. And when it goes up very high, we need it to be stable, not to fall over. So it's going to need quite a large base here, and these are going to have to be strong. What other, if you're riding on the platform, what do we need it to do? Obviously it needs to move up and down, in and out.
Needs to be flexible.
It needs to be flexible, but not too flexible.
Yeah, but it's stable.
It needs to be stable.
Mass center.
Yes, the centre of mass, it can't go out too far so that it falls over. Yes. So what about the platform? What do we want there? We need it to stay level. And this is why it is Year 8 geometry, to keep that platform level, so that as it moves around, the person in there has a horizontal floor to work on. So, what can we see in the cherry picker that is related to geometry? Where can we see this? Where can you see it?
You know, each section and each part of the arm.
Yes.
When showing with the other one, make an angle.
Yes, yeah. And these angles are going to be able to change, aren't they? Okay. So the angle in here, this is going to change. This one can go down. This one can go up and down. There's a slight difference here. This is called in English, a boom. So we don't need to worry about that just at the moment. But basically you've got angles here that change. That one, that one, that one. And we want the top one to be horizontal. What other geometric properties do we see? Some more other geometry. when we look at the cherry picker, and it's the way it's going to move, what is going to stay the same?
I don't understand the question.
We know the angles move.
Sabemos que los ángulos se
What
mueven.
stays the same?
Que se queda siempre igual.
Que cambia la energía de
Arms, yeah. The arm,
The length.
sections.
Yes. So again, this is a mechanical linkage.
Yeah.
And so this is a big long piece of steel. It stays the same length. This is a piece of steel. Here we've got, this is steel, it stays the same. The angle here changes, but these stay the same length. And the key to most of this is that we've got lengths that stay the same, and because of that, using our knowledge of geometry, we know what the angles do. So it's designed for the length to be the same, and so the angles behave properly. So we just move over and see, can I fit? This is our model of the cherry picker. You can see it's a little bit simpler than the real one there. And as I move, I can move these points. Oh. You can see how it moves. You can move this one. And you can move this one. And you can move very far. And you can see that what's happening in this model is the floor of the platform is staying horizontal. And our problem for the Year 8 geometry students is why. What makes the floor stay horizontal? So would you like 5 minutes to talk about that? What is it that is what about the geometry makes it stay the same? So you can see this is fixed, these points are fixed inside here, these two. These two are bolted onto steel. So that point and that point stay on here, but the angles change. These ones stay here, they stay there, and moves around. If you'd like to come and play, move the field, you do get a physical feel for it yourself, just moving it. So think about the geometry. Why does that platform stay level?
¿Lo entendieron el resto? La pregunta para el año 8 sería por qué la plataforma permanece horizontal, qué aspecto geométrico hace que se quede horizontal. Y lo que dijo es que si alguien quiere acercarse y manipular un poco, tener la sensación física, también lo puede hacer.
Son paralelos, sí. El segmento JL y el chica son paralelos, sí. Entonces, si tú subes o bajas, eso se queda. Si tú subes, mueves a un lado y a otro, y como cae el LK y JH son del mismo tamaño, cuando los mueves, siguen siendo paralelogramos, donde los otros paralelos quitan de vertical. Pues aplicas tu JL la tienes que establecer como que llegue siempre vertical. Es un paralelogramo, lo cual son paralelas, las dos líneas son paralelas, los dos siempre son paralelos.
Pero si KH no fuera vertical, lo de rectángulo sería.
Sí, siempre.
Claramente, si KH formar un ángulo, JL también se podría y por tanto la plataforma sería
de la suma de los ángulos de todas estas cosas.
Son porque son paralelogramos. JL, HK es un paralelogramo. tú lo mueves, pero sigue siendo paralelo.
Ya, pero si la cosa está redondita, HKF no tuviera ese ángulo, el ángulo de arriba no sería el que es.
HKL, lo importante es que esos dos lados son iguales y se mueven, igual que HF.
Si HFK fuera así, lo de arriba estaría también así.
Hombre, claramente cuando fabricas la pieza son todas paralelas entre sí, ¿no? El hecho es que fabricas piezas que son paralelas. Si miras la máquina, no hay esa pieza, no existe tal cual ahí. Lo que existe son los brazos que son paralelos entre sí.
Si dibujaran las horizontales por los sitios de unión, ángulos internos
Sí. Pero lo importante es eso, que las líneas verticales son siempre verticales. Están fabricadas para que cuando lo muevas sea paralelogramo y
se basa
siempre...
en las horizontales o las verticales, claro, lo mismo.
Do you have a proof that you can tell me?
No, not really.
Yeah, surely you do. I think you nearly do.
I don't really understand what they say.
If we draw the horizontal lines in the joint parts, okay,
Come
At right
Can you
hand
come and
points.
point? Come and show us.
we draw in the joint parts
Yes.
the horizontal lines. This angle is the same as this.
Because okay.
This, okay, we draw this parallel to the floor.
Yes.
And this angle is the same as this. Or concept, I don't know in English concept.
Yes.
Internal, external.
Yes, yeah.
And if you go up, it's the same situation. So the platform needs the same angle as, I think it's this.
Yo lo veo como un lado vertical. Yo lo veo como una paralela. La plataforma y JL son perpendiculares.
She says the platform and the segment JL are parallel. No, perpendicular.
But this is what we're trying to prove.
JL, HK siempre paralelo.
JL and HK are parallel signs because they are part of
HF
parallelogram.
y JE siempre paralelo.
HF and J.
I
I got lost.
siempre paralelo. Es una cuestión de paralelo siempre 2 a 2.
She means that all the sides are parallel to each other.
Yes.
And we've got lots of parallelograms, and those parallelograms make it.
Yeah. So we've got the parallelograms because we have equal sides. So the linkage, the steel bars, equal sides, it will always be, this will always be a parallelogram because this is equal to this is equal to this, and the same on the other two. So this one is parallel to this one is going to be parallel to this one, that one will be parallel to the top. So that if they begin, if they are at the correct angle to start with, they will always, in the end, be 90 degrees. So that's the cherry picker. I've just got one other, I'll just show you a folding umbrella if I can. Or did we try folding umbrella? It didn't work, did it?
Va a intentar el paraguas.
No, it didn't. Right, don't look at that, it didn't work. It's a very lovely, your folding umbrella, do you know umbrella?
Yeah.
When it goes down into a small, folding right down small, parallelogram, 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 parallelogram. Okay, the reason it folds and becomes parallel is because course, of many little parallelograms inside.
Hablan de cuando
When that
tenemos esos
works-
paraguas que se reducen y se hacen chiquititos, que todo eso funciona porque está formado por múltiples paralelogramos, y eso es lo que permite.
Y el tema del gato que puso antes exactamente por lo mismo, porque tiene que ocupar un poquito de espacio en el coche, pero funciona siempre. Y la máquina lo mismo, tiene que meterse en sitios muy estrechos, entonces funciona todo con paralelogramos.
This is also another example of the same sort
Es
of
que mantiene,
thing. Also for this one is the same
es
length,
lo mismo.
lines with constant length.
No sabemos exactamente
And then
son paralelos.
do you have these boxes where for tools of sewing? And they just open up and
Permite
these
el máximo
these
capacidad que es el
containers
máximo.
stay level.
Es lo que quiero, dar, lo que está intentando
So
decir.
this is also working from parallelograms.
Están hablando ahora, bueno, se ve, ¿no?, la caja de herramientas, que también se despliega y se pliega usando la idea de los paralelogramas.
Okay. And we can open the toolbox.
Wow.
Muy bien, cuando los chicos enseñan a
And can you see the parallelograms? Where are the parallelograms for this one? This one's harder for students because they have to, you can't see, you have to understand that this is one side of the parallelogram and that one. And you can see, when you trace it through, you can see that the, say,
Dice
this
que para
line,
los alumnos es
parallel
un poco
to this
difícil
one,
porque como no lo ven dibujado, el paralelogramo completo, como que
parallel to that one. So if this one here is horizontal, this one will be horizontal, this one is horizontal because you see the way they're joined up on the real box, and so this one up here is also horizontal. I just wanted to show you one more, see if I can, one more geo, can I find you one more different use of, oh, okay. have I got the, perhaps I haven't got the GeoGebra file here, but I think I can show you the sort of things we're doing. This one's with exponential functions, also done with GeoGebra.
dice que no tiene el archivo de GeoGebra aquí, pero a lo mejor a través del PDF podemos ver algunas de las cosas que están haciendo con funciones exponenciales.
So this is a different use of GeoGebra.
Es un uso distinto de GeoGebra.
Wrong way. So this is a fossil. We also use photographs of bridges, photographs of all sorts of real-world objects.
O sea, que también usan fotos de puentes y de objetos de la vida
We
real.
put the photograph into the GeoGebra file.
Ponen la foto, la insertan en el archivo de GeoGebra.
And then we can use the GeoGebra file. In this case, we have used the GeoGebra to take measurements. Perhaps you can't see
Podemos
it.
usar las herramientas de GeoGebra para medir.
Here we measured from the centre out to the outside.
Por
And we
ejemplo,
have measured the distance.
ahí está calculando como si fuera el radio, entre comillas, desde el centro hasta...
Here we measure, in this case, we measure the width of all of these chambers across their
Lo que hicieron fue medir el grosor de cada una de las capas.
el paso del
Sí, el paso, sí.
and then we are putting the data,
Y pusieron los datos.
put the data into a spreadsheet, and then we have the students look at the formula. that sort of formula,
Sí, luego les
and the students experiment that one to fit the data.
Se les da esa fórmula y los alumnos pueden ir cambiando los valores de la A, la K y la C y ver cómo se ajusta la gráfica que va resultando según modifican esos valores a los datos que tienen, los puntos, ¿no?, que tienen representados.
So, with technology and GeoGebra, it is very good for students to explore mathematics. And so here, the purpose of this lesson is so that students will understand, what does this number do? What does this number do? What does this number do to the shape of the exponential graph?
El objetivo de esta lección sería que los alumnos entiendan, ¿no?, cómo afecta a, K o C o a qué se debe o qué representa en relación a la gráfica de la función exponencial.
And it's very easy to take a photograph of water in a fountain, quadratic function.
Es muy fácil poner la foto de una fuente, el agua que cae de una fuente, y luego tratar de ajustarla con la función cuadrática.
So in this way, we are using it, we say, bringing the real world into the classroom.
Necesitamos que el mundo real esté en la clase.
And then letting the students explore so
Dejar que los alumnos exploren,
that they get a feeling for what these numbers do.
y tengan una sensación, ¿no?, acerca de cómo afecta a cada número.
So again, you can download these. I'll show you how if you need some help. And it is all Creative Commons, so people are free to change it as they like and use it.
Que todo esto se puede descargar, que si alguien tiene dificultades les enseña cómo, y que es conocimiento creativo, ¿entendí? Y que se trata de compartirlo y de...
So thank you very much. You have been a wonderful group.
Thank